Welcome back, everyone. We are now moving on to section 2.4. If we go back and address our standards one more time in this unit, so far we have done 2.1, where we were looking at polynomials and different parts of polynomials. Then 2.2 and 2.3, we started adding, subtracting, and multiplying our polynomials. Now, section 2.4 kind of takes an interesting turn. Some people think it's oddly placed, so you kind of have to like switch your mind here for a minute. But we're going to skip over this standard right here, which is I can factor polynomial expressions, and we're going to go to I can solve polynomial equations by factoring. So in this section, I'm actually going to give you a polynomial equation in factored form, and we're going to look at solving it, keeping in mind solving means you have an equation and you need to figure out which number or what do I put in order to make that equation true. And then after we're done with 2.4, we're going to backtrack a little bit and we're going to go back to I can actually factor a polynomial expression. So by the end of the chapter, this should all make sense. But for right now, if you're feeling a little off on why are we doing this, that's okay. So 2.4 is solving polynomial equations in factored form. So the first thing we're going to look at is we're going to look at, well, what is factored form? Over here on the left, we have our standard form, which we've been going over. Okay, write your answer in standard form, which means your exponents have to go from the largest to the smallest. So our first one, we have x squared plus 2x, and our second one, we have x squared plus 5x minus 24. That is a polynomial expression written in standard form. Now, comparing that to what's called factored form, these two at the top are equivalent. They are the same exact expression. So x times x plus 2 is the same exact thing as x squared plus 2x. The way we would prove that is I would take x times x plus 2 and I would distribute my x. So x times x is x squared, and then x times 2 is 2x. And if you take a look at these, they're the same exact thing. Okay, so the one on the left is in standard form, the one on the right is in factored form. If we take a look at our next one, okay, so x squared plus 5x minus 24, I have my factored form over here. The way I would prove this or show this is I would distribute it back out. So we take our first, x times x is x squared, x times 8 is 8x, negative 3 times x is negative 3x, and negative 3 times 8 is negative 24. We then combined our like terms, so we have an 8x and a negative 3x, which gives us 5x. Drop down your minus 24, drop down your x squared, and then if you take a look at these, they're the same thing. But again, the one on the left is in standard form, meaning it's been multiplied or distributed out, versus the one on the right is in factored form, meaning it's kind of been factoring. I kind of look at as the opposite of multiplication. So you multiply to get something in standard form and you factor to get it into factored form. It's kind of like the opposite version. Now that we know the difference there, we're going to look at something called the zero product property. Now, the zero product property states that if you have two numbers, and we're going to call these two numbers a and b, if a and b are real numbers, and we talked about that in section 2.1, what a real number is, and we know that a times b equals 0, then either a or b must equal 0. Okay, so think about this for a minute. If we go back to, I don't know, second grade, third grade, and I give you 5 times a box equals 0, and you have to fill in the box. Well, 5 times what equals 0? The answer to that would be 0. Okay, so if I know that the product of something is 0, I know either the first number or the second number has to be 0 in order to make that 0. Roots are the solutions of a polynomial equation. And so far, we've been dealing with polynomial expressions. The difference between an expression and an equation is an expression is just something like I have up here in this box. It's x squared plus 5x minus 24. If I were to stick an equal sign on that and say it equals 20, now I've just converted that into an equation where you have to tell me, okay, well, what value do I make x in order to get that number, which is what we're going to focus on here. Now, a couple examples before we end this video. We're going to use our zero product property, and we're going to use the idea of a root. We're going to find the roots to solve this equation. So letter A, we have 2x times x minus 4 equals 0. Pause the video, use a little bit of mental math, see if you can just use mental math and figure out, okay, well, what value can I actually put in for x that would make when I take 2 times something and then I take something minus 4, I multiply those things together and I get 0. Most of the time when I do this with students, they go, oh, I know, x could be 4. And I say, okay, let's try it. X is 4. Well, that would give me 2 times 4 times 4 minus 4 equals 0. And I put a question mark because I don't know, we're just trying it. So we substituted a 4 here and we substituted a 4 here. Well, let's see what happens. 2 times 4 is 8. And 4 minus 4 is 0. Does that equal 0? 8 times 0? Yes, it does. So if you guessed 4, our solution is 4. But then I go and I say, okay, well, wait a minute. Is there another solution? And at this point, some people get it, some people don't. This is where we start to struggle. So this is where I go back and remind you of that zero product property. Okay, the zero product property says if A times B, a number times a number equals 0, then one of those numbers has to be 0. Well, this is A and this is B. I'm taking 2x, I'm multiplying it by x minus 4, and that has to get me 0. Okay, well that means either the 2x has to be 0 or the x minus 4 has to be 0. So we kind of break up the A from the B and we set them both equal to 0, and now I have 2 separate equations. Well, if I solve these 2 separate equations, I'm going to start with the one over here on the right that says x minus 4 equals 0. The opposite of subtraction is addition, so I'm going to add 4 to both sides to solve this equation. That guy's going to cancel, and x equals 4. Oh, look at that. That's the solution that some of you probably guessed to start with, and we already checked it because we substituted it back in. Great. Now let's take a look at the one on the left, 2x equals 0. 2 times x, so I'm going to divide both sides by 2. That's going to go to 1. X equals 0 divided by 2 is 0. Well, I've got to check that. I want to see if that actually works. So I'm going to go back. I'm going to substitute in my original equation 0. So I've got 2 times 0 times 0 minus 4 equals 0 question mark. And again, I substituted the 0 here and I substituted the 0 here. So 2 times 0 is 0. 0 minus 4 is negative 4. Is 0 times negative 4 0? Yes, it is. So our other solution would be 0. So our roots of this polynomial equation are 0 and 4 because those are our solutions.